So this question came in the year 2024. Now let's try to see what this question is asking. A certain number of men can complete a piece of work in 6k days. So let's say n1 people, I don't like the color, n1 people can complete the work in 6k days. Now similarly, where k is a natural number, by what percentage should the number of men be increased so as the work can be completed in 5k days? So now the case is that n2 workers are there and they will be completing the work in 5k days. Now this even though it looks like a question from time and work, this question can easily be done using the conditions of proportionality. In proportionality, there are two conditions. So one case is known as direct proportional, one case is known as direct or directly proportional, and second thing is known as inversely or indirectly proportional. Now let's start with directly proportional. See, directly proportional is something where one thing is increasing, the other thing will also increase. Okay, for example, if you look at the example, the number of corrupt politicians, or corrupt ministers, if that number is increasing, then the corruption also will increase. So number of corrupt politicians increasing, corruption also will increase. On the contrary, if number of corrupt politicians or ministers decreases, corruption also decreases. Cases like this, we can say that they are directly proportional. When one thing is increasing, the other thing will also increase along with it. Now, since corruption is not easily quantifiable, let's take something else, the number of workers and the toys they made. The number of workers is proportional to the toys they made or the work done. It is directly proportional. Now how to write that in a mathematical equation will be, it will be like, if n1 workers can do w1 work, see, number of workers increasing will directly increase the work done, and n2 workers doing w2 work, if they are directly proportional, I can write n1 by n2 is equal to w1 by w2. Now how to remember this? You can say that if they are directly proportional, the n1 and w1 will come in the same line. Okay, so this is the case for directly proportional. Now let's look at the case for inversely proportional. Okay, inversely proportional, inversely or indirectly. This is the case where if one thing is increasing, the other thing decreases, or if one thing is decreasing, the other thing increases. For example, the quality of road. Let's say the quality of road. How to define quality? Let's say the strength of the road. The strength of the road and the number of corrupt politicians. If the number of corrupt politicians or the number of corrupt ministers increases, then the strength of the road will of course come down, because the corruption will be high. So when one thing is increasing, when number of corrupt politicians are increasing, that will decrease the strength of the road. So I can write it as 1 by s. So this thing is known as inversely proportional. When one thing is increasing, the other thing decreases. On the contrary, if the number of corrupt politicians decreases, the strength of the road will increase. Okay. Now how to represent? Again, let's take something quantifiable. The example of number of workers and days. Imagine you have 100 workers. If 100 workers will take, let's say, 5 or 20 days to finish a work, if you increase the number of workers from 100 to, let's say, 200 workers, the number of days will obviously come down. Okay, when the number of workers are increased, the number of days to finish the job will come down. On the contrary, if the number of workers are reduced, let's say I make it 50, then the days required to finish the work also will increase. So when one thing is coming down, the other thing is increasing. So here I can say that number of workers are inversely proportional to days or time required. Okay, now to represent this mathematically, what I will do is that if n1 workers can do a work in d1 days and n2 workers can do the work in d2 days, in mathematical representation will go like this. You can see, since it is inversely proportional, the number associated to n1 will be downwards in the opposite direction. Okay, now this is the case for inversely proportional. Now let's look at our case. In our question, we have number of workers and days required. So try to think, what will the case here be? Is it directly proportional? The question will never tell you that it is directly or indirectly proportional. You have to understand that using common sense. So if you look at this case, we can easily understand that when number of workers are increasing, or if number of workers increase, the days will come down. So here you can see the days have actually come down from 6k to 5k. So that probably means that, or that certainly means the number of workers have increased, assuming everything else stays together. Now let's give the answer for this case. Here we can say that n1 workers need d1 days and n2 workers need d2 days. Since they are inversely proportional, when number of workers increasing, days will reduce. I have to write it like this in the cross fashion. Now I can substitute original case, d1 will be 6k and d2 will be 5k, and so the k and k will get cancelled, and I am going to get n1 is equal to 5 by 6 n2, or if I take this 6 to other side and 5 to other side, it is going to become 6 by 5 n1 is equal to n2, or I can say that n2 is equal to 6 by 5 n1. Here we can clearly see that the number of workers, the original case we can have n1 workers and it has changed to n2. And what is the value of n2? 6 by 5. It will basically give you 1.2 n1. From here itself, one can easily say that it has increased 20%. But of course, you don't have to go through that way. We can do it in the traditional way. The percentage change in number of workers will be the new value minus original value by original value into 100. The new value n2 can be written as 1.2 n1. n1 can be maintained just like n1 itself into 100. Now if you just look at this part, that is going to become 0.2 n1, and everything else is as it is, n1 into 100. n1 and n1 will get cancelled. You will get 20%. So we can see that since it is a positive value, I can say that the number of workers have increased 20%. So the answer for this problem will be option C, 20%. Now the problem is easy, but how did I say that it is 20% just by looking at this value? That is where the same formula of this percentage change can be altered in a better way. So the formula which we have is percentage change is equal to new value, let's say n2 minus n1 by n1 into 100. If I do a little bit of manipulation, taking this 100 to the other side, it will become percentage change by 100, and then I am dividing it separately, n2 by n1 minus n1 by n1. n by n1 by n1 by n1 is simply 1. Taking this minus 1 to the other side, I am going to get percentage change by 100 plus 1 is equal to n2 by n1. Okay, taking this n1 to the other side and multiplying, I will simply get n2 is equal to n1 into 1 plus percentage change by 100. Now here, this is the same formula converted into a new fashion. This will give us a better idea. Okay, let's look at our case. When the value increased by 20%, so percentage change is equal to 20% increase. I can simply write it as n2 is equal to n1 into 1 plus 20 by 100, and 20 by 100 is nothing but n1 plus 1 plus n1 into 1 plus 0.2, and that is 1.2 into n1. See, look at this value. The new value n2, it is multiplied by a value which is greater than 1. So the original value is getting multiplied by a value greater than 1. This basically means that if something is getting multiplied by a value greater than 1, the value will increase. So of course n2 is bigger than n1, so there is an increase. Now that increase can be brought out by separating that 1. I can write this 1.2 as 1 plus 0.2, and to the 0.2, if I multiply 100 and divide 100, I am going to get n1 into 1 plus 20 by 100. You see, I basically converted this equation into n2 is equal to n1 into 1 plus percentage change by 100. Just by comparing this equation, n1 is here, n1 is here. Sorry, n2 is there, n2 is there. n1 is here, n1 is here. 1 is there, 1 is there. 100 is here, 100 is there. That basically means that 20 will be the percentage change. So whenever something is written like this, n2 is equal to 1.2 n1, I can easily say that n1 has increased by 20% to make n2. Or if I am saying something else, n2 is equal to 1.45 n1, I can easily say that the percentage change is 45%. Why? Thus again same thing will become 1 plus 0.45, or that is n1 into 1 plus 45 by 100. You see, everything else is same. This is the percentage change. And you can even go further. This is percentage increase. Percentage decrease can also be calculated like this. n2 is equal to, let's say, 0.8 n1. All you have to do is do the negative value. Just minus 0.8 with 1, you will find something. So I am going to get it as n1 into 1 minus 0.2. Where did I get this minus 0.2? Simply minus 1, 0.8 with 1. Okay. So again converting this, it is going to become n1 into 1 plus 0.2 into 100 by 100 will give you 20. Oh, it's not plus, sorry, it's minus. Here you can see n2 is equal to n1 into 1 minus 20%. This negative basically means decrease of 20%. Okay, this value can change above 1 also. If someone write n2 is equal to 2.3 n1, this also it will become n1 into, simply separate 1.3, multiply and divide by 100. This is going to become n1 into 1 plus 130 by 100. Here the percentage change is 130%. So I was just giving you an extra thing. Anyway, the answer for this problem is 20%. Whenever a problem like this comes, all you have to do is identify if it is directly or indirectly proportional, directly or inversely proportional, and after that select one of the equation, find the new value, and then simply find the percentage change. So that's it. Thank you.